So real quick, just to recap, standard form, y is equal to ax squared plus bx plus c. The axis of symmetry is the line x equal negative b over 2a. Once you know that, that's the x value of the vertex. Plug that in to find the y value of the vertex. You know that the y-intercept is just the point 0, c. When you plug x equals 0 in that equation, that's what you come up with. And like always, when a is positive, this parabola opens up. A is negative, this parabola opens downward. So let's do a couple of these. So y is equal to negative x squared plus 4x minus 5. So this is the standard form, y equal ax squared plus bx plus c. What is a in this equation? Negative 1. What is b? 4. What is c? Negative 5. Does this parabola open up or down? Down. A is a negative number. This parabola will open down. Okay. Next thing I need is the axis of symmetry. Okay, the axis of symmetry is the line x equal negative b over 2a. So x equal negative, what is b? 4 over 2, what is a? Negative 1. So what is this number right here? This is the number 4 over 2. This is what? This is x equal 2. So x equal 2 is the axis of symmetry. So when you get something like this, go ahead and graph it, because that's going to inform what happens. So x equal 2, that is my axis of symmetry. And let me just rewrite this over here. It's y equal negative x squared plus 4x minus 5. How do I find the vertex? I have to plug what in? Plug 2 back into what? The original equation. So to find the vertex, I'm going to write, I know that x is equal to 2 on the vertex. So y is going to be equal to negative, and let's just plug in what? 2 squared plus 4 times 2 minus 5. Okay, that's negative 4 plus 8. What's a negative 4 plus 8? Negative 4 plus 8. 4. What's 4 minus 5? Negative 1. Oh, you were ahead of me there. So this is equal to negative 1. What's the vertex? 2, negative 1 is the vertex. So 2, negative 1 is the vertex, okay? And this guy is going to open which way do we say? Down, right? What is the y-intercept? Please speak louder. You have to set equal to 0, which is really easy to do right here. What happens when x is 0? What do you get? Negative 5. You shouldn't have to do a whole lot of work. If that's 0 and that's 0, I'm left with negative 5. So the y-intercept is 0, negative 5, okay? So 0, negative 5 is right here. So if I know that point, then what else do I know? There's a point that matches it right there, okay? So at this point, I know what this parabola is doing. It is doing this. Where are the x-intercepts? There are no x-intercepts. This thing never crosses the x-axis. Domain, you know that answer to that? Negative infinity, infinity. What is the range? To negative 1, okay? So the domain, negative infinity to infinity. Range, negative infinity to negative 1, okay? So on the test, your instructions are going to be graph as many points as you need to get, something that looks fairly accurate, okay? What I don't want to see on the test is somebody just getting these points and just doing something like that, okay? That means you really didn't take time with this. It is curved, okay? So I'm not asking you to pick 7 points over here and 7 over here. Doesn't have to be that detailed. but you know what it takes to make it look like it should in terms of the graph. So questions over that? Does that one feel harder, different? How does that one feel? They're all a little bit different, okay? Let's look at the next one. Y is equal to 2x squared plus 8x minus 2. What is A? A is 2. B is 8. C is negative 2. How does this parabola open? Parabola opens upward. How do I find the equation of the axis of symmetry? The formula is x equal negative b over 2a. So that's negative of 8 over 2 times 2. That's negative 8 divided by 4, which is what? Negative 2. So the axis of symmetry is x equal negative 2. What's the y-intercept? It's negative 2. The y-intercept is just that number that you see right there, because if you plug x equal to 0, you get negative 2. So the y-intercept is 0, negative 2. So the axis of symmetry is at negative 2. That's right here. Yes? All righty, thank you. Okay. Okay, how do I find the vertex? I have to plug what into where? Yeah. So to find the vertex, this was what? Y equal, what was it? It was a 2x squared, what? Plus 8x minus 2. Is that it? So to find the vertex, I'm going to have to substitute x equal negative 2 into this equation. So this is 2 times negative 2 squared plus 8 times negative 2 minus 2. What's a negative 2 squared? 4. 4 times 2 is 8. So this is 8 minus 16 minus 2. So that's negative 8 minus 2, which is, come on guys, 8 minus 16 is negative 8. Negative 8 minus 2 is negative 10. So the vertex is going to be what? Negative 2, negative 10. So at negative 2, negative 10, that's this point right here. And what was the y-intercept? 0 minus 2, which is right there. So if I come over there, I find this point. Okay. Let me just double check. So if I plugged in a negative 2, that's what it's 8 minus 16 negative 8. Yep, that's right. Okay, and this one, it looks, you know, I just want to be sure I'm doing the best I can for graphing. Let me just pick another point just to be sure what's happening here. Let's just see what would happen if I pick x equal to 2. I'm just going to pick another point. So if x equal 2, then I'm going to have what? I should get the same. I'm going to get 8 plus 16, which is, oh, it's probably going to be off the graph. If I plug in a 2 here, this is 8 plus 16, 8 plus 24, 24 minus 2 is 22. I'm off the graph at that point. So this one's going pretty skinny. So I think we're okay to graph it. It's just going up like that in a hurry. Okay. What is the range of this function? Yeah, negative 10 to infinity. And domain is the broken record, negative infinity to infinity for all these guys. Okay, that's probably the one that, like I said, you have to do work because it doesn't tell you as much when you see this, but most times when you see an equation, you're more likely to see it in standard form than someone to, you have to do work to get these equations in the other two forms. So on a standardized test or when you see another math class, it's more likely they haven't done the work and you're going to see standard form and need to be comfortable graphing that. That comes later, after this test. So after this test, we'll spend time converting from one form to the next. So we'll talk about that. But for now, we're just going to, I would give you on the test. Now, on the test, I'm not going to tell you this is standard form. I'm going to say graph it. You look at it, standard form, use your standard form procedures. Vertex, use that. But later, you'll be converting between the two forms. Okay? Now what we need to do, we need to make a little bit of a progression. Once we can graph all three forms of the parabola, we need to be able to graph inequalities with the parabola. So remember when we were doing the linear programming, you graphed a line, and then what happened if I had something like y is greater than or y is less than in conjunction with that line? What did you do? You shaded above or below the line. What do you think if I have y greater than parabola or less than the parabola? What do you think you're going to do? Shade above or below the parabola. What was the other thing that you had to pay attention? If it was greater than versus greater than equal to, what did that mean? It meant the line was dotted or solid. What do you think with a parabola, if it's greater than or greater than equal, what do you think? How do you think you draw that parabola? Dotted line, solid line. That's all that's going to happen here. Okay? So let's talk about, this is what the equality looks like. This is intercept form, and this is vertex form. But I could ask you to graph y is greater than equal to, or y is less than. Okay? And that's going to, the answer there is going to be a region. So let's talk about how that works. And we'll do a few of these. So what form is this in? If you can read right here, this is a clue. This parabola is in standard form. That was a very subliminal hint that this was in standard form. Okay? So standard form, what I need to do before I can graph the inequality, remember how linear programming, before I graph the inequality, I had to graph the line. Before I can graph this inequality, I need to graph the parabola. Okay? Now, what I will do so that I don't miss points, the first thing I would do with this, when I draw this parabola, will it be with a dotted line or a solid line? Dotted. Why dotted? Yeah. Okay, this is a dotted line. This would be a solid line. Okay? That's the difference. So what I will do when I see this, I'm going to write dotted because I'm about to go do some work, and I don't want the fact that this is a dotted line to get missed somewhere in the process. So when I go to graph this parabola, it will be dotted. Okay? So what is the value of A here? -1. What is B? -2 and -2. Does this parabola open up or down? Yeah, this parabola opens down. Okay. What is the y-intercept? -2. If x is 0, this is just a -2. So 0, -2. Okay. Well, how do I find the axis of symmetry here? It's -b over 2a. So x is equal to negative. What is b? So that's -2 over 2. And a is what? -1. How many negatives are there? 3, right? 3 negatives. This answer is going to be, what's the answer to this one? -1. So x equal -1. So I know at this point, my axis of symmetry is going to be at x equal -1. Okay. The other thing is I know the vertex, not the vertex, the y-intercept is what point? 0, -2. So I know that I have to go through this point. I also know one other point without doing any work. What is it? No, it's, well, yeah, it's this point. So that point has to be on the graph as well. So what's the next point that I need to find? The vertex, okay? How do I find the vertex here? Plug in x equal -1, which is the x-coordinate of the axis of symmetry. So I've got, let me rewrite this. So let's plug in -1, so x equal -1, that's my axis of symmetry. Plug it into that equation. What's -1 squared? 1. What happens when you stick a negative in front of that number? What's minus 2 times minus 1? That's plus 2 minus 2. This answer is what? Negative 1. So the vertex is negative 1, negative 1. So the vertex is right here. Okay, which way is this parabola opening? Down, okay? I've got these points that are very tight together here. Let's just try to get one other point and see what it's doing. So let's just figure out what happens if x is 1. If I plug a 1 into this equation, that's negative 1 minus 2. What's negative 1 minus 2? Negative 3. What's negative 3 minus 2? Negative 5. So 1, negative 5 is right here. So I've got this. Now I'm about to graph this parabola. I will graph it with a what? Dotted line. This is where sometimes people are going to lose points because they're just like, oh, I've done all the hard work. Let me graph my parabola. This parabola has to be graphed with a dotted line. So all of this is graphing the parabola. Now I've got to take care of the inequality. So I've got this greater than to deal with. It could be a less than. What you want to do here is you want to pick a test point, okay, that's not on the parabola. And most times people will pick what point? 0, 0. So I want to just ask myself, is this part of my solution? If this number is part of my solution, then I will shade where? Outside the parabola. If this is not part of my solution, I will shade where? Inside the parabola, okay? So to test 0, 0, so I'm going to test the point 0, 0 and see if that makes a true statement, okay? So let's just put in a 0 for y equal negative 0 squared minus 2 times 0 minus 2. Sorry about this. This is, let me back up. It's not equal to, it's greater than, right? Is the original greater than? Okay. So I get 0 is greater than negative 2. Is that a true statement? 0 greater than negative 2. That is a true statement. That means that 0, 0 is part of my solution. So where do I shade? Yeah. This is my solution. All of that, okay? So that is my solution of the parabola. So this is one extra step that's sort of been tacked on. You graph the parabola just like we did before, but you have to take special care of if it's a dotted line or solid line. That comes from whether or not inequality has a greater than, less than, versus greater than, less than, equal to. And then you pick a test point that's not on the parabola and see if it makes a true statement. Now, if the parabola was going through the point 0, 0, you have to pick another point, okay? Question? What is it? Yeah, so if I had a parabola like this, okay, I can still pick 0, 0. If I get a true statement here, I'm shading inside the parabola. False statement is outside. But here, true statement was outside. False statement would have been inside. Okay, so it doesn't matter. But the point is, if you ever get a situation where your parabola passes through the point 0, 0, then you got to pick a different point. So pick 0, 1. Just pick another point that's not on the parabola. Okay, how does that feel? Does that feel a lot more complicated? It sounds like I'm asking for feedback, but I'm just going to keep on going with it, right? So now, because you can graph an inequality, it doesn't matter what form I give you the parabola. What form is this? This is vertex form, okay? We can graph this one. Okay, before I even do anything, when I graph this parabola, it's going to be what kind of curve, dotted or solid? Solid, okay? So I want to do that. Like I said, I'm not grading you on that, but when I grade this, I have so many people that do the hard work and then they miss points because it was a dotted and solid and they got that wrong. So let's get that out of the way first, okay? What's the vertex of this parabola? 1, 1. Up or down? Up. And here's the question. I won't always put that on a test, but yes, it's a solid line. Where is the axis of symmetry? It's what? X equal 1. It's the equation of the line x equal 1. Remember, the axis of symmetry is always the same as what value of the vertex? X, okay? We're going to be doing that till Christmas. The x value of the vertex is the same as the axis of symmetry. So at this point, I know x equal 1. That's this line right here. Vertex is what point? 1, 1. Okay. We've already established the thing opens up. So I just need a couple of points here to figure out where it's going. I'm going to pick 0. What happens if I substitute 0 into this equation? What do I get? Which is what? 2. Okay. So 0, 2 is right here. That means I also have this point right here. Okay. And we can just pick one other point. This is 0, 1, 2. Let's pick 3. If I substitute a 3 in there, what's 3 minus 1? 2. 2 squared is 4. 4 plus 1 is 5. So 3, 5. And that tells me I also have this point. So I'm going to draw this parabola with what kind of curve? Dotted, solid? Solid. Now I just need to know, am I shading above or below? How do I do that? Pick a test point. The easiest one to pick is 0, 0. So I'm going to ask myself, is 0 less than or equal to 0 minus 1 squared plus 1? What is 0 minus 1? Negative 1. You square it and you get 1. So is 0 less than or equal to 2? On Fridays it is. 0 is less than or equal to 2. It's a smaller number, right? It's less than or equal to. So it has to be one or the above, and it is one of those. Okay, so that means that 0 is part of the what? It's part of the solution. So I shade where? Outside. So I'm shading outside this guy. Okay. Pardon me? How what? Okay. I'm looking for all the y values that are less than this. Okay. So what I want to do, I'm just going to pick a test point. Okay, guys. I'm picking the point 0, 0 and just seeing, like, if I plug in a 0 for y and a 0 for x, do I get a true statement? When I plug in a 0 for y and a 0 for x, I get 0 less than or equal to 2. Is 0 less than or equal to 2? Yes. That means that the point 0, 0 is part of my solution. If this point is part of my solution, that means I'm shading all of this area. Okay. What if I got in a false statement? Then where would I shade? Inside that parabola. Okay. And I think that is it. Okay, so there are only a couple that were inequalities we did here. So I graphed an inequality from standard form. I graphed it from vertex form. You can do the same thing from intercept form. Okay. So you've got time, guys. I want you to take a look at the homework in this section. Again, I can check it tomorrow, or I will check it when I see you on Tuesday. So we're going to spend tomorrow in class. If you want to wait and do the homework, you can do that tomorrow as well, since I only got the 30-minute class. So the goal was